Yeah, hi everyone. So we will wait for 10 minutes more. Yeah, everyone. Good evening. So I would love to have this class or this like our discussion class more interactive. So I want you to be interact in this class. You can speak or you can write in the chat box. So this is a different class from your regular class. So here we will discuss problems, concepts, and even you can ask questions which is not clear during your lecture.
Okay, sir.
Yeah. I'm waiting for others as well. So we will start at 6:10. I hope my voice is clear. There is no problem in the voice. Good evening, Krishna. Okay, Raji, thank you. So have you watched the week 1 lectures? Have you completed the course on this swim portal? I want you to speak. I want you to be interactive. We are here for learning. I'm nobody to judge you if you have done it or not. It doesn't matter at all. Yes, no, not yet. That's fine. Shuchi Jindal, actually I don't have any idea about this exam. I'm here only for your doubt clearing sessions. Even I'm not a party in setting your exams and all. But I think all the exams are MCQ only. So others have watched the lectures, completed your lectures or not? I got only one response from Rajiv. What about others? Yes, no?
Not yet, sir.
Okay, it's fine. Okay, Shakshi. So do you have any idea how many students are enrolled in this course? I think it's more than 600. Okay, Rajiv. By the way, I will be uploading these lectures on YouTube as well. If you want, you can watch them later as well. And if you have any question, then you can ask in comment. I'll reply there. Yeah, so let me give you. So this is the YouTube channel for this PMRF classes. Currently there is one playlist from my last semester, and this semester this is the first class, so I'll be uploading this class soon after today. I'm requesting you to be interactive. If you know, then tell me. If you don't know, then tell me, or let me know you don't know the concepts. It's fine. So let's start. Let me check if recording is working. Yes, everything is in order. So let's start. So this is the course Solar Photovoltaics. In this course, we will study from basics to the energy generation through solar photovoltaic cells or modules. And this is the first class. So this is a discussion class, and this course is taken by Professor Ashish Garg from IIT Kanpur. And now let me introduce myself. I am Ravi Kumar, a Prime Minister's Research Fellow at IIT Bombay, and I am working in the field of solar photovoltaics only. So there are few basic questions. Why we are studying about solar photovoltaics? Why this solar photovoltaic is necessary? Even why we are researching on solar photovoltaics? Do you have any idea why we are studying about this solar photovoltaics? Why we are, so this is a renewable or non-renewable? If you can't speak, then please write in the box. It's fine. Okay, Rajiv is saying it's a renewable source of energy, but currently we are having current or electricity in our houses. Then why we are studying this solar photovoltaics? Or why we are moving towards renewable energy sources? If you want, you can speak by unmuting yourself. Is there any reason or any motivation behind this renewable energy studying or researching in the field of renewable energy? We are getting electricity from coal power plant as well. We are getting from nuclear power plant as well. Then why we are moving from, okay, Sakshi saying one thing is pollution. That is the biggest reason. Okay, then I'll take this, the only reason, that motivation, pollution, and like we can say global warming, and due to this glacier and all, to reduce the carbon emission, right Rajiv? So name few renewable energy sources we are using, or you know what are the sources in the field of renewable sources of energy. Do you have some kind of examples with you? What are the renewable sources of energy? This is the question. See, if you will be interactive, you will learn more. Any energy source or resource which is known as renewable source of energy. Oh, many. It's wind, biomass, solar, geothermal, tidal. Rajiv, right? Suchi, bioenergy, wind energy, right? Okay. So what are the sources of these? Like what is the source of wind energy? What is the source of biomass energy? What is the source of solar energy, geothermal energy, and tidal energy, even bioenergy? What is the ultimate source of energy? So people are saying wind energy. Some saying biomass, geothermal, tidal, solar, sun, right? Yes, Rajiv and Suraj, sun is the ultimate source of energy. Sun. Ultimate source of energy. I hope you know wind are the, like these are causes due to pressure difference which is generated by radiation or differential heating of earth and like ocean. Then we have biomass. It is also an hydrocarbon which is stored from the sunlight only. And then geothermal, tidal, and solar. So these are the resources or sources we are using as renewable source of energy, and these all are getting their energy from sun only. So sun is the ultimate source of energy here. So do you know how? Okay, then I'll ask this question later. So let's see. This is a photo of sun. You can see the date and time. This today's 119. So this is the zoomed image, or we can say using the telescope from this Soho. So this is the sun. The ultimate goal or the motivation behind putting this picture is only you just know the sun is the ultimate source of energy. Okay. So there are two kinds of energy from sun which we are using. Two ways by which we can generate electricity, or two ways by which we are using sun energy. Do you have any idea about this? One is written on the title of this course, photovoltaics. Heat and light, yes. Light we can say like, which is we are using photovoltaics, and heat is the other one. Yes, Rajiv, heat and light. So we will see, yes, thermal energy. Yes, JM Stephen, you are right. Thermal energy and photovoltaics. Two kind of, or two ways by which we are getting energy from the sun. Now we will see, what is this? So this is the solar irradiance. So irradiance is the power per meter square, or we can say the energy, sun energy per second, joule per second per meter square. Joule per second per meter square. It is equal to joule per second per meter square. So what is this irradiance? Irradiance here means how much energy we are getting from sun. It is not same all over the earth. So in the world we can see this is the region where we are getting high irradiance or high sun energy, and above this region the energy is low. So if you want to have a solar PV power plant, so where will you go? Where will you put it? So will you put it here in Greenland, or here in Canada, or here in Africa, Brazil, or even India? Which region will you choose? I am marking 1 and 2. 1 or 2? 2. Yes. Why? Because solar irradiance is high in this area. Very good. Regarding the sun, do you know how energy is being generated there? How energy is being generated or produced inside the sun? Do you have any idea? I want you to speak. Yes, Siri Sati, you are right. Fission process or fusion process? Fission or fusion? fusion. Yes, Dr. Priya, you are right. Fusion. It's fusion. Helium argon reaction. Reaction between helium gases. Yes. So inside the sun, 90% is hydrogen, 9% is helium, and 1% is other gases. So in the fusion, what is being held there? Hydrogen is converting into helium. So this is the fusion. Yes, all of you are right. It's fusion. Okay, now we were talking about this thermal energy and photovoltaics. Now I will show you some images and you have to tell me what is this. So do you know anything about this? What is this device is? Is it for thermal or photovoltaics? Have you seen this before?
Yes.
J.M. Stephen, right, is thermal. Yes, you can speak. Heat water. Water heater. SWHS. Water heater. Rajiv, can you expand SWHS? I am a bit confused by seeing this. Water heater is right. Solar water heating system. Oh, nice. Thank you. Okay. So this is the solar water heating systems. So it is working on this thermal principle or photovoltaic principle? Thermal or photovoltaics? So already people said thermal. Yes. So it is based on thermal. Second, then we have these solar concentrators. Do you know what is this parabolic trough? Have you read about these or do you know? Do you have some idea? Little bit about this solar power tower? The ultimate goal of these two concentrators is same. Generating electricity. But how? Anyone would like to speak? You can unmute yourself and speak. To gain more solar energy. Yeah. So you are right, Dr. Priya. The shape is for to gain more solar energy. But from here to the electricity, there is some kind of black box. What is it? Means I want to know the process. What are the steps? Okay. Do you have any idea in coal power plant how electricity is being generated? Coal power plant, nuclear power plant, any kind of power plant. You know, you have any idea? We know coal power plants are being used nowadays for generating electricity. Yes or no? Do you know this or no? Yes, yes. Then I am asking from coal. Coal is a like an stone and from electricity. So how they are connected? How this coal is being used to generate electricity? They burn coal, right? They burn coal, then they get, you can say, steam. Yes, use coal steam. Using coal they produce steam, and from steam they use steam in turbine. Then use a steam, and steam they use in turbine, and then turbine produce electricity or generate electricity. Now see, same thing is happening here. There is a pipe here, and all the radiations coming from sun like this. So all the radiations is being concentrated on this pipe, in which they have a special fluid and which is being heated. Yes, Rajiv, you are right, through turbine power generation. And using this heat, they do the same. They use the turbine and produce electricity. And same thing happening here. These are not solar panels. These are Fresnel reflector. So they reflect the sunlight, and the focus of this reflector is here, and here we have a pipe having fluid, and this fluid is being heated and which is being used for turbine to rotate or to generate electricity. So this is the one way by which we are getting electricity from sun. So thermal we are done. In thermal we are using it two ways: directly heating something like heating water, and then getting electricity. Other than that, we have solar photovoltaics. So do you know what is solar photovoltaics? Steam generation through heat of sun. Solar photovoltaics, that is solar thermal. In thermal we are getting heat, but in using sunlight for producing light or electricity, using photons is light, you can say light. So directly light or photons to electricity. Yes, so this is the solar photovoltaics, and this is the solar photovoltaic power plant. These all are solar panels. Light striking on semiconductor produces photons, thereby generating electricity. Rajiv, you are a bit wrong, but nice. Light is already having photons, so these photons generate electron hole pair, and those electron hole pair generate electricity. Photons is already in light. So any confusion here? Let's move to the next part. Yes, electrons. Yes, Rajiv. Okay, let's move to the next part. So here is the first question for you. Which spectrum is having highest irradiance in solar spectrum? And these are the options: ultraviolet, visible, infrared, all have the same irradiance. Ultraviolet, visible. Suraj saying ultraviolet, Dr. Priya saying visible. Okay. GM Stephen, ultraviolet. So let me repeat this question again. I am asking which spectrum is having high irradiance, not energy. I am not saying high energy. I am saying high irradiance. Energy is in joule, while irradiance is joule per second per meter square. I am asking for this. Okay, so three options we have: ultraviolet, visible, and ultraviolet. So this is the solar irradiance curve, and here you can see this is the spectrum. We can see this is the UV region, and this is the visible region, and all this is infrared. So what's happening here? The irradiance is here. So maximum irradiance is for which spectrum? Now you can see an answer now. Which is this spectrum is? Visible. Dr. Priya is right, so answer will be visible here. So answer is B. Any confusion here? Yes, no, maybe, no. Okay. So let's go to the next questions, which is says that the factors influencing the solar irradiance on Earth's surface is or are. So this is the solar irradiance which is coming. So this is the solar irradiance which is coming from the sun to the earth. So in between there are many factors which influence this solar irradiance. So in these questions we are asking the factors. So these are the options. And the answer here may be 1, 2, 3, 4, 5 or all of the above. Suraj saying time of the day. Suraj saying time of the day. Yes, Suraj, you are right. If 6 early in the morning we see less sunlight, so less irradiance, and at 12 noon highest irradiance. So time of the day is definitely correct. Dr. Priya saying A, absorption, scattering, day of the year, and F. Yes. Absorption, yes. Scattering, yes. Everyone is right here. Dr. Priya is also right. Malede is also right. So A, B, C and F. Note the wavelength, note the type of the receiving surface. So here you can see it depends on absorption, scattering and latitude of the location, seasons or time of the day. So these are the 4 influencing factors. And how absorption is scattering, you can see here, if this is the 100% sunlight which is coming towards the surface, so some will be absorbed in the atmosphere by oxygen, water and many other components of the atmosphere, and some part will be scattered towards this sky or toward outside, and some will be scattered towards the earth. And regarding this day of the year, like day of the year, we know we have like declination angle. We will talk about all these angles in the later part. So here we can see, so this isolation is dependent on n, and n is the day of the year. And even you can see in the summer irradiance is more, while in the winter irradiance is low or less. So it depends on day of the year as well. So day, time, absorption and scattering. A, B, C and F are the correct answer here. Any kind of confusion, or do you have any question here? Okay, so let's move to the next question, which says choose the correct. Here this alpha means absorptivity, rho means reflectivity and tau means transmittivity. So absorbance, reflectance and transmittance, there are 3 things. If this is any object and if light is coming here, so a part will be absorbed, a part will be reflected back and a part will be transmitted. So based on this question says you need to find out the correct here. So reflectivity, absorptivity and transmittivity will be equals to 0, infinite, 1 or -1. The summation of all 3. Suraj saying A, one person saying A, second person is also saying A. Suraj saying C, so Suraj is gone from here to here. Okay. And Priya saying D. Okay. Okay. Now let's do this in this way. Let's see if this is 100%. This is 100 and 10% is being absorbed. So 10 divided by 100, and some is being reflected. Let's see, 20% is reflected, 20 by 100, and some is being transmitted. So how much will be transmitted? 70 by 100. So 70 by 100 plus 20 by 100 plus 10 by 100. How much it will be? 100 by 100. It will be 1. So who is right here? Suraj. Suraj Singh Gautam is correct. Answer will be C here. Because you know energy neither be created nor be destroyed. And this light is a kind of energy. It is coming towards a surface. Some part is being reflected, some part is being absorbed, and some part is being transmitted. Is it clear? Yes, okay. Same thing is here. Alpha 2 and rho is overall is 1. So answer is C here. Okay, so let's move to the next part. So here what we are doing, we have seen the first objective, why we are talking about photovoltaics or renewable energy sources, because there is some kind of like pollution, greenhouse effect, or even carbon emission. So we are shifting from non-renewable energy sources towards the renewable energy sources. And after that we have seen these renewable sources are dependent on sun only. So sun is the ultimate source of energy. Then we have seen how sun is producing these kind of radiations. So we have seen there is kind of fusion which is happening inside the sun. That's why sun is radiating energy. And then we have seen this energy is coming towards the surface of the earth. That is known as irradiance. Now we are here on the earth and sun is very far, and sun is radiating energy towards us. So now we will see this radiation. We have seen it, some part reflected, some part transmit, some part is being absorbed. Now question comes, what are the types of radiation? So there are 3 types of radiation, which we will say direct radiation. If I am here and I am getting sunlight on myself, then I'll say I am getting the direct radiation. If I am outside or in the veranda or in under a tree, then I won't be getting any kind of direct radiation. So under a tree, what I'll get some kind of radiation, because we are able to see each other, we are able to see we are able to see the environment. So there is some kind of radiation there, and that is indirect radiation. And this indirect radiation is coming from, what are the regions of this indirect radiation? Sun is not sending any indirect radiation. Sun is sending only direct radiation. So what are the regions of this indirect radiation? What I am telling, if this is sun, my drawing is not good, and see if I am here and I am getting direct sunlight, you can say like this. So this is the direct radiation. And if let's see, this is a tree, I don't know how to draw, and I'm under this tree, even this direct radiation is being blocked by this tree. Oh, I got the answers here. Dr. A. Guru Sampat Kumar, you are right, atmosphere is the region. and other than atmosphere we have surface, and Malady absorbing scattering. You are correct. So I'm not getting direct radiation, but these radiation are going like this on the surface on an object, and it is reflecting. Here it is also reflecting the earth or the tree. If it some cloud is here, it is also reflecting. Some kind of droplets here, it is also reflecting or scattering. So I am getting all these lights, and this is the reason of this indirect radiation. So we have seen direct radiation, indirect radiation. Then if we will add both, then we will get global radiation. So direct radiation we have seen coming directly from sun. Indirect radiation we have seen, if we will both add both these, then it will be a global radiation. So now let's move to the next question based on this absorbance, radiation or irradiance. So it says, which of the following angle of incidence of solar radiation will have the higher absorbance? If you have seen the lectures, you will answer this question instantly. So these are the options: 90, 30, 0, 60 or 45. Suraj saying 30, Malade saying 90, Guru Sampat saying 0 degree. JM Stephen saying 90. See, if this is a surface and this is the angle of irradiance or incident, so I'm asking for this question for when absorbance will be maximum. Zero से 30 degree. Yes. Yes, this is the answer. 0 to 30 degree. It is written like this, 0 to 30 degree. Yes, yes. In this range it is 0.96. Yes, you are right. So you have seen the lectures. That's great. Okay. So next question. Yeah, Dr. Priya, like I think these options are not correct. This should be like 60 to 90 and 30 to 60 and 0 to 30, and it should be like we can say 45 to 60 or 30 to 45. These are the correct options here. Then 0 to 30 is the, what is the option? 0 to 30. Yeah, these options are not correct, I'm saying. According to lectures, these should be the options. If you have to choose one, then if there is 0 or if there is 30, both, if no 0 then 30 will be the answer, if 0 and 30 then both will be the answer, if only 0 then 0 will be the answer. It's like this. So next question is based on the mean solar irradiance value, which is known as solar constant. And I think you all know this. These are the options. What is the mean solar irradiance on the surface of the earth? It's 1000, 1500, 1367, 1300, 1100. What is the value? C. One answer is saying C. Second is saying C. So we have 2%, then 3, 4. That's great. C is the answer. And this is nothing but just the addition of all the radiations like we have. This is the radiance curve we have seen. So if we add all this, then the mean will be 13.67 watt per meter square. So answer here is C. Okay, so now what we have seen sun, the radiation on the surface. Now we have to see the radiation with the angle, different kind of angles. So first angle we are going to see is zenith angle. So this is the question based on this. The sun is said to be at zenith when the angle between the solar beam and horizontal surface is. It is nothing else, just asking the definition of zenith angle. So these are the options. It is just asking. Dr. Guru Sampat Kumar is saying A, 0 degree. I would say to you, please read the question again. You will get the solution. I understand what you are missing out. Malade saying E and Dr. Priya saying 90. Suraj already said 90, I think. So yes, if this is the horizontal surface and it is saying the sun is at zenith and this is the zenith. So the angle with this horizontal surface will be 90. It's like 90 minus theta z, and theta z here is 0. That's the point you are missing. Yes, it's fine. That's the point you are missing here. So answer is 90 degree. And option is E. Next question is based on a simple mathematical calculation, and that says when the zenith angle is 48.2 degree, the value of air mass index is 1.5 G. Okay. 1.5 A. 1, 2, 3. Dr. Priya is missing. 0.66. Yes. I think Dr. Priya ma'am is missing some calculation. It's fine. A is the answer. Now let me ask this question in a different way. Find the zenith angle when AM index is 1.33. Do it. Let me do it as well. My calculator is not working. Oh, it's working here. I got the answer. What is your answer? Let me know. Oh, I'm writing on this only. 41.2. Yes. Yes, 41.25. Others, if you are not getting your answer, let me know. I will help you out. This is the question. You can see this y, let's say x equals to 1 and y equals to AM index. Then from this triangle, we can see this is the right angle triangle. So cos theta will be x divided by y. And what I am asking, this x is given 1 and y is given 1.33. So theta will be cos inverse 1 divided by 1.33. Now do this calculation. Just find cos inverse 1 divided by 1.33. Yes, Suraj, 41.24. Guru Sampat Kumar ji, you are missing. AM equals to, yes, that is the same thing. So what is this air mass? We understand the formula, but what is the significance of this air mass index? What is the physical meaning of this air mass index? And in this question only, someone said 1.5 G. 1.5 G. So do you know the meaning of this G? Distance traveled by the light out the day, or path length taken by the light through atmosphere as compared when the sun would be at zenith. Definition wise, and you are correct. Now let's come to this G. Distance traveled by light throughout the day with short path. Yes, shortest path. The direct optical path length through the Earth's atmosphere expressed as a ratio related to the path length vertically upwards. Okay. Do you know something about this G? G is for global. Yes. But we are not using G here, but sometimes we use G. So what is the significance of this G? If you don't know, it's fine. I'll tell you. If you know, then please try. Because I know someone said 1.5 G. So that's why I'm asking the significance of this G. Okay, so let me tell you. G is talk about the irradiance, or what happens if this is the path taken by light. So we assume how much there is hydrogen and other gases or ozone. So based on that, we calculate the irradiance again. So like this was the irradiance curve, and we got something like this. Why? What is the reason? Why this irradiance is lower than the actual irradiance? Just go to the back question we just solved. We were talking about absorbance. So some radiation is being absorbed by ozone, some radiation is being absorbed by hydrogen or like water vapors. So due to all this absorption along this 1.5 am path, we calculate this irradiance again, and then we say 1.5 G spectrum. Yes, it is being recorded, and even like this is the channel on YouTube on which all these NPTEL videos will be available. So I'll be uploading this video soon after this class, and you can ask question there. We can discuss in the comments as well. So this is the first class for this NPTEL course. So I'll be uploading this lecture soon after this. Okay. So I hope you got the significance of this G. Yes or no? If you haven't got it, then let me know. I'll make it very simple. Okay. Okay, thank God you got it. See, be frank. If you don't know, if you have not following, it's okay. Let me know. I'll repeat it again. We are here to learn. The ultimate aim or ultimate goal is learning. It doesn't matter you know it before or not, but after today you should know this. Okay, let's move to the next question. So answer here is A. Next question says energy irradiance with air mass. So energy means irradiance with air mass. Increases, decreases, remain constant, or none of the above. What happened to this energy irradiance with air mass? You can think it logically. If air mass is increasing, what should happen to the irradiance level? Maladi saying B, Surat saying B, and Krishna Kumar saying C. Okay, let me ask a simple question. If sun is here and light is coming through this pipe here, and if sun is here and light is coming from here, this path, so which path is like here it needs to travel more? So the absorption will be more in which path, A or B? Where more absorption will be there, A path or B path? Oh sorry, A, B is the solution here, so we can say 1 and 2 so that nobody is confusing. So 1 or 2, which path? The absorbance or absorptivity will be higher on which path, or more energy will be absorbed on which path? 2. Yes, it is very simple, 2. So with the 2, AM is increasing or decreasing? So this way AM index is increasing, and also energy is decreasing. So then it will be B. Right? Yes, answer is the B. Or even you can see this is a formula which is relate this air mass index with the irradiance. You can see this is the irradiance on the earth when there is no atmospheric effect, and if atmospheric effect is there, then this formula will be applied, and due to this will decrease. So answer here is B. So Maladi or Suraj Singh is right, B. So let's move to the next question, which says, okay, now we are moving towards the angles. We have seen irradiance on the surface, we have seen the effect of atmospheric layer, we have seen the effect of any object in between, we have seen the different kind of radiation. Now we are moving towards angle. If any object is here and it is like at different angle, then what will happen, or some other angles as well, or depending on the day or time of the year. So next question is based on declination angle. So it says Choose the correct with respect to declination angle. I hope you know declination angle. What is it? Do you know what is this declination angle is? Someone is joined, so I am just giving my YouTube channel link so they can follow the lecture there, because it has been 1 hour and 10 minutes. Angle of the sun with respect to equator. Yes. Then choose the correct. Solstice or equinox. So will it be 0 at solstice and maximum at equinox? Oh, Malade is saying D, and Krishna Kumar is also saying D. What about others? Suraj Singh is also saying D. That's great. Okay. You all three. Oh, HOD, BME, HOD. So maybe other ID. So yes, HOD, you are also right. It's D. So it is like here. We can see these are the solstice time and these are the equinox time. So at the equinox it will be 0 and at the solstice it will be maximum, that is 23.45. Yes, yes Suraj, you are right. So answer is D here. 23.49. 23.45. Suraj, I think there is some confusion in the lecture as well. It should be 23.45 only. Yes, Marley, 20.45. Okay, so let me ask you few questions. Oh, we are moving to a very interesting part, that is angles. So this is the last part of today's class. So we will read or we will study about all these 5 angles. We will understand what these angles is. So do you know what is hour angle? What does it signifies with the name of angular measurement of time? Yes. So it will be 0 at the noon. See, one circle is 360 degree and how many hours is there? 24. So 1 hour will be, in 1 hour how much degree? Angular measurement of time in 1 hour, 15 degree. Yes. And we see at the 12 noon we take this angle omega 0 at 12 noon. Angle between observers. Okay. So at the 12 noon we take this our angle 0 and before that we take it negative and after that we take it positive. So this is the angular measurement of time. Here we can see if it is 10 a.m. then it will be minus 30 because 2 hours before. If it is 2 p.m. it will be 2 hours after, so it will be 30 positive. Okay, so next is declination angle. Declination angle, so you already told. Even here you can see, if this is the earth and like it is like this, and we can see this is the plane, one plane of earth, or other plane is for sun. So there are two planes. So the angle between these two planes is our, so this angle is fixed. What is this? I am saying this is the plane of earth, and if this is the plane of sun, you can see. So they are not with the same plane or in the same plane, so they are in the different plane. So that's why the radiation coming, if like this is sun and this is earth, so radiation coming from the sun towards the earth will differ at different position, and when these planes are crossing, so it will be zero. So it is known as solstice. Like here, sorry, equinox, it is zero at equinox and it is maximum at solstice. So here we can see these are the equinox and these are the position of solstice. So that's the declination angle. Next we have elevation or altitude angle. Altitude angle is very simple. We have read it in trigonometry as well. So anything at any altitude making an angle with the horizontal surface. Like here you can see this is the horizontal line and this is an object, so the altitude angle here is this one. So this is the altitude angle. Now next angle is zenith angle. Zenith, so we have already seen, any angle, if this is a zenith and this is an object here, and if it is making any kind of angle with this vertical zenith, so this angle is known as zenith angle, phi z. After that we have solar azimuthal angle. Solar azimuth angle means if we just take the reflection of this object in the ground or in the ground, and then that angle from the north south line is known as azimuth angle. So now I'll show you an interactive platform where you can see these angles very clearly and you will understand them. So wait a minute. So this is a platform known as pveducation.org. Here if you will go to this first introduction chapter, then solar energy, you will see, and then properties of sunlight. Here you can see the sun, and here we have terrestrial solar radiation, atmospheric effect. We will go one by one. Even you can do any kind of calculation here as well. So this is the radiation. This is the sun and earth. What is the distance, what is the radius, and how much radiation we are getting here. This is the formula. And using the day of the year, you can find out. Here you can find out any time or intensity at any point of time. So let's move to this angle part. Declination angle. First see this thing. You can see. Yes, I'll share this link. I'll link it in YouTube as well, and I will share here as well. Even it is pveducation.org. So here you can see this is the earth moving around the sun, and now what's happening with the radiation, here you will see. So see, this is now solar radiation angle is like minimum 0, and now it is maximum. Now it is 0, now it is maximum. So that's the declination angle here. In the static picture, we can see the sun radiation with the earth. Here it is maximum, 0, and other maximum like positive and negative. So this is the part of declination angle, and this is how it varies. Now let's see elevation angle. Here you can see this is the elevation angle. Sun is rising, and this is the angle it is making with the earth. So that's known as declination. Oh sorry, that's known as elevation angle. And next here, this is the declination angle and zenith angle. You can see like here, this is the elevation angle, and these are the sun's radiation, and this is also saying all three angles. And this is the zenith angle. Zenith angle is with the vertical line, and this is like 90 plus, 90 minus zenith is elevation, or 90 minus elevation is zenith, or zenith plus elevation or altitude is 90 degree. Now let's move to this next one, that is azimuth. So here you can see the reflection of sun is taking on the ground, and then that angle from the north is being measured. That is known as azimuth angle. So here once again you can see this is the like picture of sun on the earth, and then its angle from the north. That's azimuth angle. Here you can see it clearly. So these are things will be taken up in the tomorrow's class, local solar time and local time. So this is the pveducation.org platform. You can go there and you can play with the animations. And in this course, this website will be very useful. And if you have any doubt, then you can write in the comment box on the YouTube, or you can ask in the discussion channel as well. I hope that's it. Yeah. So that's it for today. If you have any doubt or any question, you can ask now, or if you have missed any part of this lecture, I am going to upload this video on YouTube right now. You can watch it there and you can ask question there as well. Once again, this is the channel link and I'll be uploading this video very soon. And thanks a lot for being interactive. I want you to be interactive more, so it will be a fun for both of us and it will be a good learning as well. Okay, so I'm going to stop this class now. You can or leave, or if you have any doubt you can ask. Thanks everyone for joining. You all are welcome. Okay students, thank you.